Food. It fuels our bodies, feeds our souls, changes the environment, inspires artists, influences politics, and impacts just about every part of our lives. When people say you are what you eat, they're actually kind of right. We live in a unique slice of history. Our modern world no longer is faced with an issue of scarcity, but instead suffers from a paradox of plenty. However, this slice may be slimmer than we realise. Over the last 100 years, our planet's population has quadrupled. 1915 saw the start of the Industrial Revolution, birthing large-scale agriculture, which was a driving force behind this boom. Today, there are 7.6 billion people on Earth, according to recent estimates by the UN. If current growth predictions are correct, we may reach 9.7 billion in the next 30 years. That means 2.1 billion more mouths to feed. An alarming number, considering that now, in 2020, 815 million people around the world are suffering from chronic undernourishment. That's 1 in 10. Current estimations by the FAO see food demand to increase by 70% by 2050. And the task of growing this food isn't getting any easier. Climate change is already having a devastating impact on our ability to grow crops, with agriculture being the second highest contributor to greenhouse gas emissions and one of the leading causes of deforestation, biodiversity loss, and water pollution. We need a system that sustains both us and our planet, which would require systemic change along the entire supply chain. Thankfully, innovators from around the world have been working hard to make this change happen. Over the course of this film, I want to take a look at some of the bleeding edge technology that could change the way that we grow, distribute, and consume food, and could potentially provide the solution to feeding the world of the future. $1.6 billion tons of food is wasted each year. That equates to a third of all food produced globally. The land used to grow this wasted food makes up an area 58 times the size of the UK, or almost 3 times the size of the Amazon rainforest. In the book Food Foolish, authors John Mandick and Eric Schultz translate that statistic into relatable terms. Imagine buying 3 bags of groceries, or driving home, toss half of one bag onto the road. That represents the loss that occurs during harvest, processing, and distribution. Arrive home and immediately toss the other half of the bag into the trash. That's the waste experienced by retailers and consumers. James Rogers is the CEO and founder of Appeal Sciences, a Californian tech startup backed by the Bill Gates Foundation, who have developed an edible spray coating that, when applied to fruit and vegetables, massively slows down the rate of spoilage, promising to dramatically reduce food waste along the entire supply chain.
The product itself is plant oils. So they're found in literally every bite of fruit and vegetable that you eat every single day. They're the materials that give the cells their structure. So every cell has a bunch of stuff going on inside of it, but it's wrapped up in a little capsule that makes it a cell. And so those capsules control what goes in and out of the cell. So by taking that structural building block material, we isolate it, we mix it back up with water, and then we apply it back to the surface of the plant. When it dries, the molecules dry into a structure. They arrange themselves in a way that physically impedes water going out and oxygen going in. And because of the ratios of the plant oils that we select, we're able to control what structures they form. And by controlling that structure, you control the properties. We can slow water loss rates, for example, by up to 4 times. So if something normally lost, 4% of its water per day, with Appeal, it can lose, 1%, which means that we can have a mandarin that sits on your counter for like 100 days, which is like crazy to think about.
So for a product with this much obvious potential, why aren't we already seeing it used everywhere?
When I got into this, I was a PhD scientist by training. And so the idea was, well, we'll just, obviously a piece of fruit that lasts longer is more valuable than a piece of fruit that doesn't last longer. So we'll just make a piece of fruit that lasts longer and we'll have a successful business. Well, unfortunately, there's no market for a longer lasting piece of produce. If I went to Tesco and said, I have 2 Hass avocados, one of them that lasts longer and one of them that doesn't last longer, they're not willing to pay any difference in price because it's not something they bought before. It's not something that they have quantified the value. Our work was much more difficult than just creating the technology. The other side of this was figuring out, if you do have extra time, how does it create economic value? Longer shelf life means more time to sell the fruit on a shelf, so you throw away less, which means that you sold more of what you bought, which means you made more money from the extra stuff that you sold. So what we're really doing is we're using technology to create time, and then we're using a business model to quantify the value of that time and then sell that time.
So what role do you think Appeal has to play in strengthening food security in the future?
Food waste is actually reported as the #1 way that we can reduce our climate impacts as a species. So we're working on food waste for exactly that reason. It's going to have the largest impact, the most immediate impact on the climate. But the way the food system is set up today, it benefits people who are participating in it, but there are a lot of people that aren't participating in it. And so when I think about Appeal's contribution, it's actually about expanding the scope of the food system, building it on a wider foundation so that it's more inclusive, so that A, more people have access to nutrition, and B, more people are able to sell this natural resource that they have access to. But we're out of shortcuts in doing that. Like, the food system was like this, and we use shortcuts to get it like this, but we're at the edge of it, and now every shortcut we take is polluting the planet. And so, I really view Appeal's opportunity is to, recognize the rules of the system that we're in, which are the rules of the natural world, which are the laws of nature, and then work within those rules to build a food system that is wide enough to encompass, the 10 billion people that we're going to have on this planet.
This is dirt. Well, soil actually. And although it may seem pretty unremarkable, it forms a foundation for every ecosystem on the planet. Without this, life on Earth would begin to disappear pretty quickly, and it's under threat. Intensive mass-scale agriculture is responsible for a loss of fertile soil at the rate of 24 billion tonnes a year. If this continues unchecked, we could completely run out of arable land in the next 60 years. With this being a very real possibility, agri-tech companies around the world are looking to a future without it. This is through the method of hydroponics. You may have already seen this technology elsewhere. NASA have been growing food using hydroponics on the ISS since the 80s, with the method set to feed the first colonies on Mars. Here on Earth, however, companies are scaling up production to be able to feed entire populations. I wanted to know more about the process, so I spoke to a representative from Thanet Earth, the UK's largest hydroponics facility, spanning 222 acres over the Isle of Thanet in Kent, which alone grows 12% of the UK's entire annual yield of salad veg. Hi Sally, how are you?
Yeah, I'm good, thank you. How are you?
I was hoping you could tell me a bit about the hydroponic system at Thanet Earth.
Yeah, okay. So all our plants are grown from seed. We plant them on 3 centimetre cubes of this rock wool. So what I'm talking about there is using rock wool slabs. It's a good inert substance that you can grow in and input precisely what you want for nutrients and precisely what you want for watering. When that plant gets too big, the whole cube gets inserted into a 10 centimetre cube. These are then put onto slabs, which are put onto these suspended gutters in the greenhouse. Each plant will have 1 dripper per plant, and that is how they're fed. All these gutters are on a slight gradient, so any excess that goes through the rock wool will drain out and back into a mixing tank where it is cleaned with UV filter, checked for electrical conductivity to see what has been taken up by the plants, and then recirculated round again. It's again quite economical because you only give the plants what they need. It takes about 26 lorries to bring them all in. From planting to first harvest is 8 weeks.
So, what are some of the benefits of using a hydroponic system compared to a traditional farming method?
So the land where we are now used to grow brassicas. So you got broccoli and cabbages, whatever. Now, if you put a field of broccoli down, you'd grow broccoli and you'd harvest it once. Whereas with our greenhouses here, just for tomatoes, we will be growing the tomatoes for 365 days of the year. We've always got tomatoes being harvested. So you can imagine the food production by metre square is obviously a lot more high intensity. If we're talking sustainability, at the end of a crop, all the green parts of the plant are shredded and used as soil ameliorant. All the rockwool bases is also chopped up and reused to be made as bricks, or again, it's chopped up and used as a soil ameliorant on fields. So we're quite proud, what is wasted goes back.
How far away do you think we are from being able to be self-sufficient in this country by using hydroponics?
We still, in the UK, only grows 10% of what we consume. So there's a long way to be able to be self-sufficient in crops. I think our cucumber greenhouse, you'd need something like another 30 greenhouses like that to be somewhere towards being self-sufficient for cucumbers in the UK. We still rely on a lot of imports from Spain and Netherlands for our product here. So the UK is still way behind. So there's a lot that still needs to be worked on. It's just not there yet.
Growing food is tough. So since the start of our species, we've been creating tools to make the job easier. And as time has gone on, they've been getting better and better. Now in 2020, the latest step in this evolution is the use of artificial intelligence and automated robotics. There are many ways in which this tech is being utilised, from robots programmed to harvest and maintain crops, machine learning algorithms to detect soil defects, or satellites used to predict weather and crop viability. Around the world, growers are facing the issue of a declining labour workforce. This is because as economies grow, the percentage of the population that go into agricultural work shrinks. When tasked with feeding a growing global population, this is a pretty big deal. Tortuga AgTech, based in Denver, Colorado, is an engineering startup that has developed their own line of autonomous farming robots, and who believe that this technology could help to provide the answer. Eric, could you tell me a bit about the role of automation in farming?
There is so much work to be done to grow the food that we all eat. Robotics can help with, what a lot of people call the dull, dirty, dangerous jobs. I don't think it's realistic that robotics would ever make a human being who's willing to do work on a farm completely obsolete. If we can provide a robot fleet that can do the picking job and maybe some other jobs on the farm that are cultivation related or jobs that humans can't do because they're too dangerous, we'll do those jobs and help those people do more high value add jobs on farm. The idea of co-robotics is more promising than the idea of trying to make a fully automated system. Co-robotics being, again, the robots doing the dirty, dull, dangerous work, but the humans overseeing and making sure things are still going well and dealing with the nuances and the complexities of the farm operation, which will never go away. Robots may not be as good as a human being at being very, very dexterous right now, but they have perfect memory and humans don't. So as a person goes through and just picks more fruit than you'd ever imagine in an hour, a robot will go maybe a third as fast, maybe a half as fast as the very best. But they'll do it for 10 to 20 hours. And as they go, they'll remember every single thing they see. And that information can be used to help the grower make better decisions.
How could automation help growers defend their produce against the challenges that are facing us in the future?
Think of the growers' challenges and falling into three main areas. The first challenge that they face is the environment they're in. So, I choose to grow a particular crop or set of crops. I live in a particular part of the world. I face a climate and I face pests and other pressures based on where I am and what I'm growing. You've got the labor challenge, because ultimately farming is mostly just hard work. Like in the physics sense of the word, it's work. And then the last component is the information challenge. I don't know what is happening, so I don't know how to make the decisions of what work to do. Hydroponics, or whatever you want to call it, combined with sort of controlling the environment right around the crop, significantly can improve your plant health, your yields. If the robot then comes in, you basically accelerate all those benefits extraordinarily, because now you have a system that's better for the environment, better for yields. Also, then a robot can pick for you, which can save you money. A robot can collect all the data for you, which helps you to control those pest pressures even better. So all of these things kind of really work together to address those three major challenges the grower faces. You stick a robot at the heart of the grower's problems and solve the challenge for them, all of a sudden everything starts working together in this really healthy system.
Do you think at some point in the future, farmers as we know them today, pitchfork, tractor, will just be a thing that we read about in history books?
I think they may look very different than they used to. In 1900, that really was a pitchfork person, and it was a homestead, and there was a farmer and his wife with 7-8 kids, and they all had a job to do. Now those farms are highly automated, but you still have that family there. They're just a very different set of skills now. That they're not out there literally digging in the dirt to get the rocks out of the field. So it looks different, but I don't think it will go away.
We are a planet of meat lovers. Globally, we consume 315 million tons of the stuff every year, with this infatuation showing no sign of slowing down. Livestock production increased nearly 5 times in the second half of the 20th century, with predictions showing that by 2050, meat consumption could increase by as much as another 160%. This rising demand is having some pretty severe consequences. The impact that it has on our planet, the drain on global food and water stocks, the inhumane conditions inside battery farms. This isn't a system that we can keep up for much longer. While many are choosing to go vegan or to use plant-based alternatives, what if I told you that in the years to come, you will be able to eat meat, real meat, without any of the environmental or moral repercussions? Meat that isn't reared, but cultured inside of a lab. Although meat grown out of a lab may sound like an idea ripped straight out of Blade Runner, researchers at the University of Bath argue that this may be less science fiction than it seems.
So cultured meat is essentially animal tissue, so typically muscle, that is grown separately from the animal. So what that entails is we will take a biopsy from a live animal. We then separate out the muscle stem cells, and then we introduce those cells to a reactor, which they can have all sorts of different configurations. Those cells are attached to a scaffold, so a material that they can grow on, and they're provided with the nutrients and the oxygen and the water and everything that those cells need to grow. And we grow those up, we amplify the number of cells that we have, and then you can direct them to differentiate into proper muscle tissue, and then you take that tissue off, and that's where your meat comes from.
What would be some of the benefits in shifting away from livestock rearing and towards cultured animal products?
Yeah, so the major benefits really are about water and land usage. There was a study, I think, came out in 2011, so it's quite old at this stage, from Oxford, but it suggested that a shift to cultured beef rather than sort of traditionally reared beef could reduce water usage by up to 96% in the industry and land usage by 99%. Of course, the problem with the land usage is that in traditional agriculture, the reason we need so much land is to grow the meal for the cows, so whatever it is that you're rearing. And that land is normally made available through deforestation, which has huge impacts on biodiversity, it impacts on the environments and the wildlife within them. Really, the third point, environmentally anyway, is the greenhouse gas emission. By some estimates, traditional agriculture actually contributes more greenhouse gas than the entire transport sector. So, being able to curtail that by using this cultured meat system, it would be huge.
How far away do you think we are from seeing cultured products available at a consumer level? And once they are, will we start to see traditional animal agriculture be phased out?
So, of course, the industry has exploded in the last 5 years, hundreds of new startups coming along, hundreds of millions of dollars of investment by some highly influential billionaires. Bill Gates, for example, Sergey Brin is the co-founder of Google. So there is a lot more money coming into it, and that is predicted to just keep rolling. And if it does, then we're going to see a huge acceleration. As ever, it's a bit of a joke in the industry, really. Whenever somebody asks you, how long until we're going to see cultured meat on the shelves? The industry answer is, 5 to 10 years, in the next 5 to 10 years. But actually at this stage, that does seem to be more of a reasonable estimate. And in fact, some of the largest startup companies seem to be saying that they'll get their cultured meat products in high-end restaurants and on supermarket shelves in the next 3 to 5 years. So, it really depends on who you ask. It's unlikely that we'll see a complete phasing out of traditional agriculture, mainly because the technology will require incremental biopsy of muscle tissue from animals. So ultimately there will always be a cow in a field somewhere. Difference is that cow could be reared to a very, very high quality of life. Obviously that's great because ethically we have these free-range cows that are able to just live it up and do whatever they want. But we're also then producing the best quality cells because these cows are then exposed to much less stress. They're not kept in these factory farm, I suppose, conditions. You don't have as much antibiotic needed to use on those animals. So the meat that you get at the end is actually better quality than you would get otherwise. I do think it's unlikely to see a complete phasing out. The way the technology is being established, we're going to see it as a supplement to traditional agriculture just to meet that protein need we're going to have with increasing global population.
With systemic change being the message driving this film, I think it's fitting that it was made during a time where all of our lives are going through massive transformation. We're currently in the middle of the COVID-19 pandemic, which has forced us to rapidly alter so many aspects of our society. Our healthcare system, our jobs, our social interactions. Our food system arguably was one of the worst affected. We're all too familiar now with the sight of empty supermarket shelves. We've read stories of dairy farmers dumping thousands of litres of milk away as demand dries up, and heard the reports of millions of animals being culled or depopulated due to slaughterhouse closures. Seeing how susceptible our current supply chain is to disruption, there's never really been a more important time to focus on ways that we can change it. Change it to one that's not only more secure, but better for animals, better for us, and better for our planet. And what's become clear over the course of making this film is that through forward thinking and through innovation, we have the ability to make that change happen.